as an intermediate concept between arrays and passing arrays as arguments to functions, we need to know about pointers. So let us see some slides about pointers, the basics about pointers. So a pointer is a value indicating the number of the first byte, that is the value of the first byte of a data object. It can be integer or double anything, also called as address or a location. So here the value 11 occupies 4 bytes. This 4, 5, 6 and 7. The starting location is represented by the pointer, that is 4. So this is used in machine language to identify which data to access for the current process. The example is stack pointer is the address of most recent entry to the stack. That is the top of the stack. So usually 2, 4 or 8 bytes are used depending on the architecture we are using in the processor. So here the memory addressing, again the same thing is used, and we are referring the starting point of the block assigned to the particular value. So there are addresses of memory location in a 32-bit machine architecture. So pointers in C are used in many applications. So for building useful, interesting and data structures, we need pointers to represent the first block of the data, first byte of the block of the memory. For returning data from the functions also we need pointers, and for managing arrays also we need pointers. So to represent the pointer, we are using a prefix ampersand with the variable. So if you want to know the pointer of variable x, we need ampersand x, and for getting a value of the integer x, we are using address of the x because we are storing the value in that particular address. This is not a bitwise AND operator, and unary asterisk operator dereferences a pointer, gets value pointed to. So that is the address. Here it returns the value pointed to. So one example is given with an expression. So asterisk p equal to x plus y. So we are adding the two values x and y, and we are storing it into that particular location represented by. So first example is a pointer to an integer, second one is pointer to a double, third one is a pointer to character. So we are using char here. Another one is without a type. There is a type can be user defined one. So pointer to an object of type. The example, so it can be a structure or union or any function or user defined. Pointer declarations, we need to read from right to left, not from left to right. Then only we can understand it clearly. So for here, for the example, constant integer asterisk p. So p is a pointer to an integer constant. So pointer can change thing it points to not. And another one is integer asterisk constant q. So you read it from right hand side. So q is a constant pointer to an integer variable. So previous one, the pointer can change, it is not constant. but here the pointer is constant one, so it cannot change. And another example is constant integer asterisk constant r. So r is a constant pointer to a constant integer. So the integer also cannot be changed and the pointer also not changed in that execution. Now, let us see some basic pointer arithmetic. So basic operators we can apply with pointers. So here we have two pointers, p and q. You add 1 with p, that is you increment p by 1 and you are assigning that value to q. So construct a pointer to the next integer after p and assign it to q. That is the next location of p is assigned to q. In another examples, double p and r. These are two pointers for doubles p and r, and we are adding the value stored in the location p with the integer value n, and we are assigning it to the location r. So n may be negative also. You can, in negative case, you subtract the value from p. I already told here we are using it as a intermediate concept between arrays and passing arrays as arguments to functions. So let us see what is the necessity for this. Arrays and pointers are closely related to in C, because if you are passing an array and as an argument to the function, you need to give the first location of that array, that is the pointer of the array. So here an example is given. We are using an array A with type integer and size 10, and we are getting the address of A in P, that is P equal to A. We are assigning the first location of array A to P, and you can assign the values stored starting from the location P to A also. So these are two reverse one, two vice versa concepts. The first one you are getting the address of A, the second one you are assigning the values stored in the address P to A.